Hello, friends, a podcast to introduce comparing two means or two proportions. So this podcast generalizes to both. So as opposed to a match pairs experiment that we did in class today, where you can subtract one value from another and get a single list of numbers, which are the differences. When you have two means, you're talking about two samples of different size which don't have a one-to-one correspondence. So I need to use a two sample or a two proportion test or a two sample or two proportion interval. We still have our same conditions, needs to be random, normal, and independent, and there are similarities in these. You can see both populations are normally distributed or the sample sizes are big enough because we are talking about means. Same thing goes for independence. As long as the population is reasonably 10 times bigger than the sample size, we're good to go. And again, the point of random is just that the makeup of the sample needs to be as similar as possible to the makeup of the population. We have an entire new set of notations, not new, I guess, only that there is a subscript 1 and a subscript 2 by the variable, the population mean, the population standard deviation, sample size for two different groups. So now these can be two different numbers. And we have statistics, X bar and X bar, or it could also be P hat and P hat, and standard deviations for both. Easiest way to illustrate this is to just look at an example. You can turn in your book to example 13.2 and read what's going on here. But we're comparing two different groups. One has 11, one has 10. And the 11 and the 10 come from 21 healthy black men. And we're going to randomly select a group of 10 men to receive a calcium supplement. And we are going to leave the other 11 to receive the control or placebo pill. Now, this should remind you of the experimental designs we did earlier in the year, like September, where we took a study population, we randomly split them into two groups. In this case, they're different sizes. They were both going to receive different treatments, and we were going to measure the results. The groups need to be randomly selected, and there needs to be some kind of control, either a placebo group or two things that can be compared. The people who are receiving the treatments need to be blind. In other words, they need to not know what treatment they're getting, and the people that measure the results need to be blind. They don't know which people got which treatment. At the end, you compare and see the difference. Well, this compare part is the part we didn't really cover in much depth earlier in the year, but now we have the tools to actually get a p-value and talk about how different the two results are. So we have two different ways that we can write a null hypothesis now. Again, it's a null hypothesis. We're going to assume there's no difference between the calcium treatment and the placebo. So we're going to assume that the mean of the first population is the same as the mean as the second. And we can subtract. So these are actually the same thing. And in this case, the alternative is that we think the calcium mean will be greater than the placebo mean. And that means if we subtracted placebo mean from calcium mean, we get a number bigger than 0. So we're going to assume there's no difference, and we're going to find a p-value, which is going to tell us the probability that I would get a result, a sample statistic, an X bar that high, if the null hypothesis about mu is true. So that's step 1, just talking about the hypothesis and the population and parameters of interest. Step 2 is the conditions. You can see we've got random here. You can pause and read or read in your book. We've got independence here, which is pretty straightforward. I want to take a minute to talk about normal. Also in your book, or you can pause the podcast. But what they've done here is taken the two samples and done normal probability plots. So you should be able to do this. I illustrated this today in class in the calculator. Okay, but you can see this pattern is either straight or tails that go in opposite directions, like both of these do. So it's reasonable to say that these populations are normal enough. I've got a z statistic that I can use here if I know sigma, and if I don't, I use the t statistic and use the standard deviation from the sample. And I have the same tools at hand to get a t statistic or a t confidence interval. So what I'd like you to do is take those two lists of data, put them in L1 and L2, and do a two-sample t-test using L1 and L2, so using data. Give that a try.